Okay, now we're going to look at combinations. So, first example, as part of a grade 12 English course, students are required to read the following 3 books in a 3-month period. So we have The Grapes of Wrath, The Wars, and The Bean Trees. Due to previous late returns, Steve is only allowed to sign out 1 English book from the school library per month. List all the different orders in which Steve could sign out the 3 books. He has 3 choices for the first book he wants to rent or take out. Then he has 2 choices, then he has 1. So 3 factorial, which is 6. So there's 6 different ways that he could rent this out. And it might be easier. Let's say this is G, so Grapes of Wrath is G, The Wars is W, and The Bean Trees is B. So we could have gone GWB, or GBW, or WGB, or WBG. Okay, or lastly we could go BWG and BGW. So there's 6 different ways that we could arrange this. But rather than writing out all those arrangements, we can just use factorial. Or the fundamental counting principle. Or, how many books do we have? 3, and we're picking? 3. That would equal 6 as well. So there's a few different ways you can do this question. Now, Tariq is allowed to sign out all 3 books at the same time. How many different ways can he sign out all 3 books at one time? Grapes of Wrath, The Wars, The Bean Trees. Does it matter the order of how he collects the book? No, he's taking all of them. There's only one way. So, I'm just going to ask you guys a question. In part A, did order matter or did it not matter?
It did.
It did matter. Because he's only allowed to take 1 book out at a time. So he's going to either read The Grapes of Wrath first, The Wars first, or The Bean Trees first. Whereas Tariq, does order matter? No, because he can take all 3 and then just do what he likes. He can read them as he wants. Okay, so part A is an example of a permutation. Order is important. Part B with Tariq is an example of a combination where order is not important. So important definition here, a selection of a set of elements in which the order of the selection is not important, we call this a combination. Okay? So order is important for permutations, order is not important for combinations. Alright, part 2. Suppose that the students in part 1 were required to read only 2 of the books. Okay, there's still 3 selections. Complete the table to show the number of ways in which Steve and Tariq could do this. Okay, this is a bit time consuming and I hope you guys don't do this on a test. It's pretty much like a tree diagram. Okay, so Steve using permutations. We could take out the Grapes of Wrath, so G and W, so Grapes of Wrath and The Wars, or Grapes of Wrath and The Bean Trees. Okay, or we could take out The Wars and the Grapes of Wrath, or we could take out The Wars and The Bean Trees. Okay, lastly we could take out The Bean Trees and The Wars, or The Bean Trees and the Grapes of Wrath. Okay, that's where order matters. For Tariq, combinations, order does not matter. So he could take out the Grapes of Wrath and The Wars. Could take out The Wars and the Bean Trees. Or he could take out the Bean Trees and Grapes of Wrath. Okay, order doesn't matter. So where we see G and W, GW, WG. That only occurs one time for a combination. For the for the wars and the bean trees, once, and so 2 permutations is equal to 1 combination. Okay, and then lastly we have the bean trees and the grapes of wrath, once, and there we go. Couldn't find it. Okay, the number of combinations is equal to the number of permutations divided by what? 2. Or we could say 2 factorial. A permutation is an arrangement of elements in which order of the arrangement is taken into account. And a combination is a selection of elements in which order is not taken into account. Okay? So just keep in mind, permutation, we're talking about arrangements, combinations, selections, order doesn't matter. Okay, we're just going to do another comparison of permutations and combinations because it's really important to know from examples when order is important and when it isn't. Okay, so 5 students, Al, Byron, Colin, Dave, Eric, take part in a cross-country race to represent their school. Suppose the winner of the race wins $50, the runner-up wins $25, and the third-place runner wins $10. The table below shows all possible ways in which the 3 prizes could be awarded to the 5 participants in the race. So instead of Al, Byron, Colin, Dave, and Eric, they just used A, B, C, D, E. Okay, so the first letter of their names. So here we have the list of all the different ways of how we could pick winners. Okay, so it could be Al, Byron, or Colin, or it could be Al, Colin, or Byron. Okay, so that's first, second, third, people in different places. So if we were to count that all up, would you want to count it all up? No. So how could we calculate that quickly? First we need to decide, is it a permutation or a combination? Does order matter if you have a first place winner, a second place winner, or a third place?
Yeah.
You care if you win first?
Yeah.
Well, I would, so you win more money. So,
oh yeah, so it does.
So it does matter. Yeah, order does matter. So this is an example of a permutation because order matters. Okay, so for example, here Al got first place, and he has a few opportunities of that. Okay, here Colin got first place. Here Dave got first place. So they're winning the $50. Okay, order matters because you want to win that $50. So how many ways are there to award 3 prizes? I think you said it before, Chris. How many people do we have? 5. And how many can win prizes? 3. Good. Okay, or you could have written that as 5 times 4 times 3. Alright, for the next part, for participating in the cross-country race, the school has been awarded 3 places at a running clinic. The school coach decides to select 3 lucky students from the ones who took part in the cross-country race. So in this case, does it matter if you're picked first, second, or third? Do you still get to go to that running clinic? So the order of the names that are chosen, does it matter? No. So in this case, it's a combination. Okay, and how many ways could we do that? Well, let's just take a look at the list that's given. So we have ABC, 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 ABC. Okay, that's ABC's all used up. Then we could do different arrangements of A, B, D. Does it matter that their names are in different orders? No. Okay, same thing here. So how many different ways do we have to pick 3 names? 10. Okay, so we could have gone, in this case, how many students do we have? 5. We're going to choose 3. And we haven't used this yet in our calculator, but I'll show you a little early. Okay, so we have 5 students. And you go to math, over to probability, and number 3, we're choosing 3. And you get 10. Okay, so at the bottom here, the number of combinations is equal to the number of permutations divided by what? So we had 60 permutations. If it has to equal 10, then we had to divide by 6. Okay, as a factorial, what equals 6? 3 factorial. Okay, and we're getting that number from the number of students that we're going to pick. So this gives us the combination formula. So combinations of n different elements taken r at a time. It's basically looking at the number of permutations divided by r. So this right here, that's the equation for NPR. And then we're just dividing by another r factorial. Okay? So n elements, choose r at a time, is equal to n factorial divided by n minus r times, factorial times r factorial. This formula is on your formula sheet, and the n pick r at a time is also on your formula sheet. Okay, so you don't have to memorize those. Okay, and we just went through the NCR key, or the combination key. Okay, you probably wouldn't see this on your diploma, but just be aware that combination could also look like this. Okay, N, R. It's nice when they have the big letters though, right? You know when it means combination or permutation. So we have 3 students from a class of 10 are to be chosen to go on a school trip. Okay, do you think the order of the kids that they pick is important? No, it's not like the first person they pick gets like this comfy seat or something, okay? It's just 3 in general. So I'm just going to do the answer for part B first. First, we have 10 students. We're going to choose, how many go on the trip? 3, yeah, 3 students from a class of 10. Okay, so on our calculator, let's just figure out the answer first. So n choose 3, what do you guys get? 120? Perfect. Now I'll show you using the formula from above. Alright, so we started with 10 students, or 10 elements. In our equation, we're going to then go 10 minus 3 factorial times 3 factorial. Okay, and that's because our n is 10 and our r is 3. We have 10 students, we're only taking 3. So if we were to simplify this, we'd get 10 factorial over 7 factorial times 3 factorial. If I weren't using a calculator, I could simplify 10 factorial to 10 times 9 times 8 times 7 factorial, divided by 7 factorial times 3 factorial. 7 factorial can cancel out, and then I can go 9 divided by 3. Oh, sorry, 10 times 9 times 8. Don't forget, this is actually like 3 times 2. Okay, so 9 divided by 3 is 3, and 8 divided by 2 is 4. So then I get 10 times 3 times 4, which is 120. So that's the long way about it. We could have also just plugged this into our calculator right away. Okay. So to win the Lotto 649, who's looking for that? Can you guys even buy tickets? You have to be 18. Okay, a person must correctly select 6 numbers between 1 to 49. Jasper selected the 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, 29. How many different selections
Junior class change.
of the numbers could he have made? Let's just finish on this one. Chris has got to win the lottery. Okay, how many numbers are possible? 1 to 49 is? There's 49 numbers. We need to choose 6 of them. Okay, and that would work out to be, oh boy, 13,983,816 possibilities of the number combinations you could have. Do you see why your chances are so little?
Why do you pick?
So when you buy a lottery ticket, you need to pick 6 numbers.
But he's saying he's going to pick those from those 6. So when you choose 6, because he's saying he's
So
only pick.
he did pick that, but how many different selections could he have made?
Oh, got it.
Not how many did he make.
Okay.
Okay. We'll pick this